Hi all, welcome to pantechelearning. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. This video, edge detection. Edge detection is one of the most important part currently being used for many. Once when you go for this detection, you have to know its type, why it is moved. So inside this edge detection, whenever we are working, have very kind of phosphorus technique which detects only the edges of a particular object inside an image. So inside this technique, we are going for the points identified, like what I have just for the segmentation, different segmentations, allotting that particular area. So like that, it's not a clumsiness. Now here I can provide you a clear clarification. Edge. Inside this edge, it is also a particular type of segmentation only. Cannot be that as a different technique or different part of segment, but only the boundaries will be able to. That will be major difference edge and segmentation. Now here we are taking an image as considered present. So onto that in how the segmentation also this will be I'm just segment this part and this image will be that I'm going to segment it. This will be that particular portion segmentation. Now the same thing if you want to come for the reduction only this triangle direction. How that particular triangle and the edge of the same has been. So this is the major difference edge segmentation. But from that particular parent of the edge segmentation only, because we need to segment that image, and from that segmentation only we are taking only the boundaries of the respective targeted object. So for that particular purpose only the edge reduction. Now we are seeing many kinds of object reduction, person identification, chain detection. For all that particular process, this edge detection is only the part that our artificial intelligence, all the requirements. Once, whenever you are working regarding toward this neural networks or training the objects into the neural intelligence, for all the parts, this will be our planted technology to train the device or to train that particular objects or the data sets for everything. This will be that end termination we apply in the form of edges. Now inside these edges, what are all the technologies available? The edges itself we have many. So here we can split this edge into the two types. As a gradient and another one is the Gaussian. So inside the segmentation we have seen both the gradient as well as the Gaussian. Especially if we are using the Gabor filter, we are just going with the gradient side, and inside that also Gauss filter is being applied only for the reconstruction to remove the noises. The same thing if you are just moving on towards the previous k-mean clustering, k-mean segmentation, k-means, those and all comes under the clustering group of data. And if you go for the binary or the threshold images, those comes under the Gaussian. So like this kind of different varieties are there for the segmentation itself. The same techniques only here also it is applied for edge. Like inside the gradient, we have three types like Sobel, pivot, and robot. The same thing if you go for the Gaussian, canny, Laplacian of Gaussian. So this kind of different techniques only is completely applied inside edge detection. From that, around the worldwide, whatever the techniques are famous means canny as well as the Sobel. So inside this particular video, we will be just seeing for the entire function of canny as the Sobel, including their own difference. So that differences only the slight changes will be there. The codings also like a simple executions for the coding, and that particular simple technique you can apply it for your own projects or whatever the image processing requirements running everywhere we can take it for the trainings as well as the requirements. Now let us see what are the theoretical difference. Theoretical means the technical part. From the technical, what are all the advantages or what are the points will be covered in that particular image. Now here you can see that particular image. So inside that image itself, you will be having an idea. So how that particular canny will be obtained as output. This will be that replica. So what and all the process will be taken inside the canny? It's nothing but the image smoothing. Differentiation will be there. The suppression there won't be at the maximum level. So what is that image smoothing? We have seen the smoothing even for the noise removal techniques. Whenever you are converting one form of image into another, the image should not be blurred over, or at the same time it should not be sharpened over. So that comes under the part of image smoothing. So which maintains or balances the level. The same thing if you go for the differentiation. then every targeted object must track inside the. So here you can see the hair, those kind of small identifications you can see clearly inside the canny detection suppression. So that image is not supposed to be compressed or to remove all the filters or whatever that particular backgrounds are there. Okay, much suppression won't be there. Same thing if you go for the Sobel, based on the gradient, the intensity, here the suppression will be there, and that suppression won't be the improper part. And for that particular suppression, there are many lack in that particular suppression as well as the gradient. It is not focusing on a particular object. That will be the major difference. Will be able to feel this kind of Sobel as well as the canny. Now, if we go regarding towards the applications, it is used for medical imaging, anatomical structure study, locating an object in satellite images, traffic controlling systems, face recognition, and fingerprint. So these are all the different applications listed for the detection. Now if we go for the coding, let us start with the coding for edge detection. So first, let us start with the global edge detection. So here I'm just trying all our basic commands like clear all, those kind of requirements, and close all previous windows, CLC. Here, if I just apply one image to get as input, IM read for any one image, I'm providing 0.jpg. Then after that, that respective image we can change into grayscale, IM to gray. Now we can make it to display. Only that gray image will be displayed over here. Then after that, we can add our edge detection part for this. Now therefore, first we are going with Sobel. For this our keyword is edge, and within that we have to provide the parameters like what are the grayscale converted over there, that variable should be provided, and here we have to provide it as Sobel because that only we are going to apply here. That's the reason. And after that we have to display that image. So for that I am show SO, that will be the variable. Okay. Now let us run this. We have to save that to the grayscale, and this will be the Sobel part. Okay, so this comes for the Sobel. Now the same thing we can add it for the canny. So for that we have to just add only two lines. So that one line that belongs to H E comma, instead of Sobel we have to add it as canny. Then again we can just display it name show PA. On that theoretical based on explanation, from that if we just compare, so you can see how accurately we are able to get that particular edges over here. So here all the patterns we can recognize, but here only that particular outline. So for our application, which is best, we have to choose that respective algorithm for our purpose. Now the same thing if I am just adding with another image means putting.png. So inside this we have this variation. Here we can see that here it's little bit clear and here it is clumsy. So this figure 2 comes for Sobel. And the same way we are just going for the other images. There we can see how the changes are there. Here it is marking only the dots. Here the entire image it has been taken. This is applied for even all the medical requirements and that medical exemptions kind of functions over here. Now the same thing what happens if I apply a direct color image. So this is completely color image only. It cannot accept that. The reason is whatever the edge direction it is getting supported only for the purpose of two-dimensional black and white, not for three-dimensional. So here we can get that particular error. Here we can get that error. So the reason is our data is not two-dimensional. That is the main reason. For that only we are converting into the grayscale. In this way only the edge detection can be applied for all the images, and as well as the video processing can also be done for this. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel. Thank you for watching our video. If you like this video, kindly click on the like button and share the video to your friends. Don't forget to subscribe our channel.